Okay, Ji, we are starting off with remainder factor theorem. This is topic that I tested in P3. This is also topic that is tested in O-level add maths. And obviously A-level maths, right? So what you need to understand is that, let's say, remember the way we used to divide? Let's say we have 25 and we have 7. That means we are dividing 25 divided by 7. So 7 3s are is what? 21. So the remaining is 4, right? So we can either have it in the points, but what we remember is that this 7 is basically your divisor. This 25 is your dividend. 4 is your remainder. And 3 becomes the quotient. So this is a normal division method, right? So what we can have here is that if we say that dividend is basically divisor multiplied by quotient, right? Plus remainder. So if we just reverse work to this, 7 multiplied by 3 plus 4. So this is 21 plus 4 becomes what? 25, which was your dividend, right? So this is normal way of doing a division number or dividing it, right? But we will have long algebraic methods as well. Long division. We'll have long division. Let's say that we have x minus 1 as your divisor, 4x cube minus 3x squared plus 8x minus 12. Now this entire thing becomes your dividend. So what we're going to have is we're going to use the long division technique, and the long division technique will help us to find out the quotient and the remainder. So let's say that we have x minus 1, right? So this x minus 1, what should it be multiplied with that you will be getting 4x cubed? Obviously, 4x squared. So when I multiply 4x squared with x, I'll be getting 4x cubed. And this should be 4x squared. That means 4x squared multiplied by minus 1 will become. So that means the first number in the quotient will be 4x squared. So that means we can write this thing down as 4x squared. And here at the bottom, when 4x squared is multiplied by x, we get 4x cubed minus 4x squared. And this thing will be then obviously subtracted, but we need to change signs, right? Because this thing is already in plus. So we can have this thing in negative and this thing is negative, we can have this in positive. But knowing the fact that 4x cube and this 4x cube can be now cancelled out. So what are you left with? 3x square plus 4x square is basically x square. So we write down this thing as x square. And the remainder follows out as 8x minus 12. Now, considering that we already know that the factor that we have is x minus 1. Now, with what number will I be multiplying this to get what x square? So I'll be multiplying it with x. So this will become x square minus x. So that means plus x. We write down this thing as what? Plus x. And here we're going to write down x square minus x. And then we're going to again subtract the same condition. Plus becomes minus and minus becomes plus, sign change. This and this is cancelled. So what you are left with is 9x now. Minus 12. Now looking at this, again, we know we have x minus 1. Now what we're going to multiply x with is 9. Because we need 9x. So 9x minus 9. But here what we're going to do is, we're going to write down the value at the top, which is 9 plus 9. And here we're going to have 9x minus 9. And then this thing, the signs will change again. Plus becomes minus, minus becomes plus. This thing is cancelled. Minus 12 and plus 9 becomes what? Minus 3. So what we have in the end is that this thing is your quotient. This was your factor, that is divisor. This is your dividend and this becomes your remainder. Minus 3 becomes your remainder. With the help of what? With the help of normal factor being multiplied with what? The normal number to have the quotient. So this was your long division technique of dividing any algebraic form with the factor that is given. Let's work down with the formula technique again so that we know. Since we know this, that the formula is dividend. Let me write this thing down. Dividend is basically your divisor multiplied by quotient, and what you're gonna do is plus remainder. So your divisor here was, no, we already know the dividend. The dividend was 4x cube minus 3x squared plus 8x minus 12 is equal to, your divisor that we had was x minus 1. The quotient that you got was x squared, 4x squared plus x plus 9. 4x squared plus x plus 9. And the remainder that you got was minus 3. So let's say when we multiply x with 4x cube, we get 4x squared, we get 4x cube, we get what? X squared plus 9x minus 4x squared minus x and minus 9 minus 3. So 4x cube minus 3x squared. We already know 9x minus becomes what? 8x minus 12. So this becomes the answer. That means using the formula, you can end up getting the dividend when you have the quotient, divisor, and the remainder with it, so that you can easily get the dividend as well. So considering the same thing approach, this thing is very easy considering that we know that what is the divisor, quotient, and remainder to have what? Dividend here. Let's say we know the divisor, which is x minus 1. We know the dividend, which is 4x cubed minus 3x squared plus 8x minus 12. So we need to find out the remainder and the quotient. Now, one technique that you already know is the long division technique. The other thing that you need to understand is that you already have this one factor, that is x minus 1. Out of 4x cube, out of this 4x cube, we already have 1x. That means the other thing should be ax squared. The other factor should be of square, because square multiplied by x will give you x cube. So a quadratic is generally summarized as what? Ax squared plus bx plus c. So when we know this, that one technique is the divisor. So that means this 4x cube minus 3x squared plus 8x minus 12 can be used with x minus 1, because this is already there, but the other thing that you have is ax squared plus bx plus c, and you do not know the remainder. Again, why did I pick up on the x square? Because when this x square multiplies by x, you get what? X cube. So we know that it's a quadratic form. Now, if you just open this thing up, so this should be 4x cube minus 3x square plus 8x minus 12, which can be used as ax cube plus bx square plus cx minus ax square minus bx minus c plus r, right? Because obviously this thing is multiplied. Now what we're going to do is the comparison method again. And the comparison method states that x cube should be compared to x cube. So your a becomes what? 4, right? Similarly, you already know that we have what? X square. But x squared is minus 3x squared, which can be compared to bx squared, right? And minus ax squared. So minus 3x squared can have b minus a x square, and x square is cancelled. So minus 3b minus 4 minus 3 plus 4, b becomes what? 1. B becomes 1. On the other hand, what we have is x. 8x can be compared to cx minus bx. So 8 is equal to c minus b. 8 is equal to c minus 1. 8 plus 1 is equal to c. C becomes what? 9. So we already know that we had ax squared plus bx plus c. So this is 4x squared plus x plus 9. We got the same dividend. We got the same, I mean to say quotient. Now, knowing the fact that we already know the quotient here, and the factor generated with this was of x minus 1, right? This was the factor. So this factor can only come when the remainder is what? We can equate it with what? Assuming that the remainder is 0, because the factor is there, right? So what we can do is we can always have x minus 1. We can always have what? X minus 1, knowing the fact that x minus 1 is equal to 0 and x will become what? 1. So that means that quotient, let's say we have fx is 4x cube minus 3x squared plus 8x minus 12. So if we put down 1, so 4 1 cube minus 3 1 square plus 8 1 minus 12. This f1 will give me what? Minus 3, which will be the remainder because there is the factor there. So this can be used as a technique when we will not be using the long division method, and we can directly solve the value using without the long division method.